Now, what if I have an oblique impact? In case of oblique impact, at least one of these two velocities will have an angle with the line of impact. But since I have an oblique impact, which means each velocity can have two components, then I'm going to have four unknowns: VAX, VBX, VAY, VBY, for example, after the impact, if I know them before impact. How to solve this? I have four unknowns, which means I should have four equations. What are these equations? The first two equations are the same equations as the central impact. They are the conservation of momentum along the line of impact. And the second equation is the coefficient of restitution always along the line of impact. So I have two equations. They are the same as the case of central impact: the conservation of momentum along the line of impact and the coefficient of restitution along the line of impact. Now, what about the remaining two equations? The remaining two equations are the conservation of momentum of both particles in the perpendicular direction of the line of impact separately. What does this mean? I should apply the conservation of momentum of A in the perpendicular direction of the line of impact, and I should also apply the conservation of momentum of B in the perpendicular direction of the line of impact, which means it's not the same as the first one. It's not the conservation of momentum for both particles as one system. It is A and B. So I should apply the conservation of momentum of A, and then I should apply the conservation of momentum of B in the direction that is perpendicular of the line of impact. Now the question is, how can I say that the sum of impulse of forces for particle A alone is equal to 0, so that there is a conservation of momentum in the perpendicular line of the line of impact? For example, guys, if this is A, at least this A will have a weight, and this weight will have an impulse. I know that the impulse is the weight times time. So at least, guys, this weight will have an impulse. How can I say that MAVA before impact is equal to MAVA after impact, as if the impulse of the forces exerted between T1 and T2 on A is equal to 0? How can I say this? In fact, guys, from the first definition of impact, I said that the impact occurs during a very short time, which means, guys, this dt is very small. So if I multiply this dt by any force, the weight force or any other force like the tension, for example, I'm gonna have a neglected term. And that's why the sum of impulse exerted on A on the perpendicular line of impact will be equal to 0, because all the forces times this small tt will be equal to 0. And that's why I can apply the conservation of momentum of A in the perpendicular direction of the line of impact, and then I can apply also the conservation of momentum of B in the perpendicular direction of the line of impact. And in this case, in the case of oblique impact, I'm going to have four equations. The first equation is the conservation of momentum for the system of particles, because as I said, the impulse forces will cancel out because they are opposite. The second equation is the coefficient of restitution. The third equation is the conservation of momentum of A in the perpendicular line to the line of impact. And the fourth equation is the conservation of momentum for B, also in the perpendicular line of the line of impact. Thank you.